All you need is courage and love, because they're always with you. This is a favorite quote from my favorite hero, who I look up and admire too. And the hero's name is called Anpanman. He's the one who supported me throughout my life. Despite the fact, I asked my colleagues, 32 of my colleagues, that question, do you like Anpanman or not? And you can see from figure 1 that 65.7% had answered that they either do not like Anpanman or they're not interested in it, sadly. I asked the same populations this question, do you think Anpanman is strong or not? Where his strengths is one of Anpanman's characteristic, you can see that 59.4% had answered that they either do not think Anpanman is strong or they're not sure about his strengths. However, I would like to look at this video, a clip from Anpanman's anime. Please wait, it's loading. And you can see that his Anpanman's eternal enemy, Baikiman, is defeated by only one punch, showing his invincible power. Therefore, I strongly believe into his power. And so in this presentation today, I would like to present my favorite hero's power and probably persuade you that he is actually strong. However, a subjective fact that he is strong would not convince anyone, so we need an actual data here. Power in terms of data, as you know from your physics classes, is joules. And please look at this diagram here. It is a simplified diagram labeled figure 4 of what's happening when Anpanman punches Baikiman. You can see here that energy is created when Anpanman punches. That guy should be rushing. And then mass of Baikiman himself and his machine holding a certain mass flies at a certain velocity. So what kind of equation includes all these kinds of information? It's the equation of kinetic energy, as you know from your high school. K is equal to half times mass times velocity squared. So this is today's outline, and I would like to find each of the variables in order to conclude the kinetic energy. Going back, first I'd like to start off with the mass. And going back, the mass refers to the mass of Baikiman and his machine, which is this thing. However, we don't know what this thing is made out from. But thanks to the father of Anpanman, Yanase Takashi, he said in his interview that Baikiman's machine is actually made out from SMA. What is an SMA? It's shortened for shape memory alloy, a metal that remembers its shape at certain temperature. And according to Tsukuba University, this is equal to 6.3 grams per cubic centimeter. You can see from the equation by eliminating a cubic centimeter part. So the volume, you can find out the mass. So we need to find out here the volume of Baikiman's machine. Given the fact that Baikiman's height is 102.8 centimeter and finding out the relative lengths of each part of his machine and plotting that into the CG model, I've actually found out that his machine's volume is 0.716 meters cubed. And the mass is 4,511.2 kilograms. You might think that I'm forgetting something. That is true. I forgot the mass of Baikiman himself. According to the father of Anpanman again, in his interview, Baikiman is made out from germs. So what is a famous type of germ? The one bacteria that lives in our large intestine, E. coli, weighs about 1 picogram. I'm not sure if you can see, but it says 1 picogram, 10 to the minus 12. And multiplying that by Baikiman himself, Baikiman actually weighs 7.91 milligrams. Pretty light. So the weight, or the mass, isn't actually 4,511.2, but in fact it's 4,511.2000791 kilograms. You can see that how that's insignificant. Something about it over before. We found out the mass, we need to find out the velocity here. So what's velocity? As you know from your elementary school, it's equal to distance over time. So I'm going to find these factors out. Firstly, looking into the time by actually measuring the clip by a stopwatch or something, I found out that the time is equal to 2 seconds. Now we need to find out the distance. By observing the video clip itself, we could see that Baikiman disappears at a certain time, which indicates that he went upon the horizon. So this is a simplified diagram of the distance until the horizon. You can see the triangular circular shape. And thanks to Pythagoras, he found out that c squared is equal to a squared plus b squared. The r here is the radius of Earth, and that's, by geology, we know that it's 6,371 kilometers. So we need to find out h here. H refers to the height of Baikimon above the ground. So to find out, I separated the height h in two parts. h1, the height of Baikimon above the tree, and h2, the height of tree itself. By adding the in, we can see that height is height h. And first looking to h1, by brute force, it could be found out that it's 4.74 meters. And we need to find out the next factor, h2, the height of tree itself, which is this thing. The only given information here is that we have a white trunk, a green leaf, and a typical silhouette of a tree. Which in real life, the most educated guess to be made is this thing. Which in fact is called a white birch, or in the binomial nomenclature, Mitsuna platyphylla, and in average at maturity it grows to 25 meters. So we found out both variables, we could now calculate the height h, which is equal to 29.74 meters. By putting back to the original equation, now we can find out that this is d, which equal to be 19.4 kilometers, so Baikimon actually flew about 20 kilometers, pretty far. And putting back to the original equation, I found out the velocity of Baikimon flew is actually 34,920 kilometers per hour, which is 28.3 times of the speed of a sound, pretty fast. We found out the mass and velocity, we could find out the kinetic energy at last. The kinetic energy equal to be 424 trillion joules, which is equivalent to 6 times of a nuclear. In fact, if Ampamon punches the ground of Ota City from the center, he will destroy the whole city, creating a crater diameter of 24 kilometers. And due to his high energy punch, his surface of knuckle rises to a temperature of 467,634 degrees Celsius, pretty hot. Now, at last, I hope that I was able to persuade you guys that Ampamon is strong, but not only that, he is a disastrous man. Thank you very much, and this is the end of my presentation.
Taiga, it is a very interesting presentation. Any questions, comments?
We need to, oh, thanks. My friend Daniel.
Thank you for your nice presentation.
Thank you for your question or comment as well.
Why did you decide to search this project?
As I mentioned in the very first point, a superficial reason would be that the fact that I like Ampamon. But in truth, probably that won't persuade anyone because at this age, liking Ampamon is a little bit weird, as you know. The actual reason for studying in this kind of thing is that I watched a YouTube video online where it looked into a fictional phenomenon and applied some scientific rules on it. And that the animation or the fictional thing that it looked about is called Tennis no Oji-sama. And they create fires by swinging the tennis rackets and what jewels it's created and so on. And that seemed to be really interesting. So in this presentation, I wanted to do something that's related like that. And therefore, Ampamon was probably one of the most well-known, as well as probably to the Japanese. Most of the Japanese people, they know the characters, so they could relate in some form, as well as could be interesting because usually it is exaggerated in the form when Ampamon punches lightning, he just flies over really long distance. So yeah.
Thank you for your answer. It was really a nice presentation.
Thank you very much.
Thank you. Please give a big hand.